My name is Ashish Palekar. I'm a product manager with the EBS team, and I take care of our Snapshots business. Welcome to this reInvent session, where we'll be covering how to cost optimize your enterprise workloads with Amazon EBS. Here's our agenda for this session. A very brief overview of EBS. Then we'll talk about changes in our stream volumes, how to manage costs for EBS snapshots and armies with Data Lifecycle Manager, cover a new instance type, R5B, talk about tiered IOPS pricing with IO2 and IO2 Block Express, use of elastic volumes to reduce your costs, and finally, the integration of EBS with the AWS Compute Optimizer. Let's get started. So when we think of the block storage portfolio within AWS, we really look at four different things. We look at the EBS volumes and what our volume types are. We think about snapshots, which are copies of EBS volumes that are stored on Amazon S3. We think about instance storage, which is your temporary block storage that is attached to the EC2 instance. And then we think about data services. For this session, we will focus on the first two, specifically the volumes and the snapshots pieces. When we talk to customers about why they choose EBS, it really boils down to a few key things. Customers love the performance that EBS volumes give them for any workload. They get reliability in terms of availability and durability, and they get ease of use in terms of adding capacity, changing volume types, and in general being flexible. And they get this on the core foundation of virtually unlimited scale without trading off security or cost effectiveness. And this is the EBS volume portfolio. We have GP2, GP3, we have IO2, IO1, we have ST1 and SC1. And as you can see, across these volume types, we support a wide array of workloads. From NoSQL databases, think Cassandra, MongoDB, CouchDB, to relational databases, think MySQL, SQL Server, SAP, Postgres, Oracle, to big data analytics, like Kafka, Splunk, data warehousing, and all the way to file and media for CIFS and NFS file storage, for transcoding, for encoding, for rendering. But this session is all about saving you money. And so there are changes across each of these volume types that we have introduced that reduce your overall TCO. So let's get to it. Start with our stream volumes. So when we think about stream volumes, let's start with SC1, which is our cold HDD volume. It is designed really for sequential throughput workloads such as logging, backup copies, as a retention tier, really designed for a baseline throughput of up to 192 megabytes per second with a burst that gets you up to 250 megabytes per second. Its capacity ranges from 500 to 16 terabytes. It is our lowest cost volume type offering. So customers came to us about cold HDD and said, can you make it more cost effective? Because it would allow us to store data for longer on EBS. And that's precisely what we've done. So SC1 used to be priced at 2.5 cents a gigabyte a month. Just in November, we have dropped prices by 40% to 1.5 cents, right? So if you were paying X, you're now paying 40% less. And that makes us ask the question, have you considered tiering your colder workloads to SC1? Because if you aren't, this might be a fantastic way for you to optimize some of your workloads. So now let's take a look at our other HDD-based volume, which is ST1. We call it throughput optimized. It comes with a baseline IOPS and burst IOPS that take it up to 500 megabytes per second. From a capacity standpoint, it also goes, much like SC1, from 500 GB to 16 terabytes. And it is really designed for large block, high throughput sequential workloads. So when we looked at ST1 and SC1, one of the other areas that customers gave us feedback on was, we love what they're doing, but man, we have workloads that need far less than 500 GB. can you look at reducing the minimum size of these volumes? Because that would save us money. And that's exactly what we've done. So new at reInvent, what we've done is started with the minimum size of 500 GB, which is what it used to be, and both for ST1 and SC1, we have reduced that size to 125 GB. That's a 75% reduction in the minimum size. How does it make a difference to you? So here's an example. Let's say in this case, a customer needs 100 GB of cold HDD volume for their workload. Prior to these changes, they would provision 500 GB at $0.025 per GB month, which meant that within that month, for that volume, they'd be paying $12.50. With this change, what they can do is now provision 125 GB, since that's the new minimum size, and they would be paying $0.015 per GB month, which means that their total cost is $1.875. That is 85% lower. The combination of these two changes mean that we would see more customers looking at these volumes as ways to tier their storage within EBS, and we are excited how customers will use our SD1 and SC1 volumes. Next, we take a look at how you can manage your snapshots and armies with Amazon Data Lifecycle Manager. Let's start with a core problem statement. Customers used to take snapshots all the time, and they came to us and said, we really don't have a means to take snapshots and define how long to keep those snapshots. And the net result was customers' snapshots would proliferate, they would have copies, and really didn't have a good way to manage their costs. So about 2 years ago, we launched Amazon Data Lifecycle Manager. And what it does is automates the snapshot lifecycle management. You can set policies that allow you to either at the volume level or at the EC2 instance level, take regular snapshots and retain copies of those snapshots, and fully integrates with CloudFormation. So if you are looking at snapshots and snapshot costs, you can set policies on when snapshots are taken and how many snapshots to keep in a lineage. And we use cost allocation tag to keep tracks of snapshots. Here's the screenshot of how you would do it. You'd create a lifecycle policy. You would then set a policy schedule. In this case, it's one every 2 hours. And then we keep 24 copies around. And that defines how many snapshots. And customers have used Data Lifecycle Manager for a lot of different use cases. And we've been busy making further improvements to DLM. We initially started with 12-hour and 24-hour cycles. We've now gone to 1 hour. Customers can now use cron expressions. Policies creation is simpler, and customers can store multiple schedules within a single policy. We now allow time-based retention, and so customers can do daily, weekly, and monthly schedules on their snapshots. And now you can also copy snapshots across regions via DLM policies. All these give you a rich tapestry of options in order to store your snapshots and manage your costs. But we didn't stop there. Customers came to us and said, love that you're managing snapshots, but what about Amazon machine images? And turns out, Amazon machine images, which are, think of them as copies that are used to boot EC2 instances. So if you're booting an EC2 instance, you'd use an army. They are backed by snapshots. And turns out, customers were taking those or creating those armies much like they were creating snapshots. And they were keeping copies of those armies, especially as their build images change, they would create new armies, and so they had proliferation challenges on armies as well. So what we've launched and what the team did is take a look at that problem and essentially now incorporate army lifecycle management also within DLM. So you can now identify your EC2 instances that you need to back up. You can automate the retention and cleanup of armies. You can control costs by deleting snapshots of deregistered armies. You can retain backups for compliance and auditing, and all of this is free to use, right? So again, if management of your snapshot and army costs is a challenge, then think about using Amazon Data Lifecycle Manager for your workloads. So we didn't stop there. Now we took a holistic look from the instance side. And one of the challenges that customers run into is when you connect either a multitude or a single EBS volume to an EC2 instance, oftentimes, if they have a storage-intensive workload, they will run into the maximum amount of throughput and IOPS that a single EC2 instance can drive. We call this EBS optimized throughput and EBS optimized IOPS. What happens is when you run into that limit, customers then have to tweak their workload, which means they have to scale it horizontally by putting it on more EC2 instances. If it's a database, you're changing your database schema and then accessing it off of multiple nodes. It not only increases management complexity, it not only increases the cost in terms of EC2 instances, but also in the case of commercial databases, increases the licensing cost for those databases. So customers came to us and said, can you do something about it? And in partnership with the EC2 team, what we've launched, again, new at reInvent, is a new instance type. We are calling this the R5B. It is up to 3x better in terms of EBS performance over the comparable EC2 R5 instances. So what that now means is from a single R5B instance, you can get up to 260,000 IOPS and 7,500 megabytes per second. To put this in perspective, previously you could get 80,000 IOPS and 2,375 megabytes per second. If you have workloads that are, think of it as large database or data analytics workloads that you've had to shard horizontally, this is a great way for you to consolidate those workloads, bring them onto a single instance, and take advantage of both the cost savings from reducing your EC2 instances, but also reducing your licensing costs. Again, awesome to see this in customer hands, and we are excited to see what customers can do with it. On the storage end, we now want to turn our attention to IO2 and IO2 Block Express. So in August of this year, we launched IO2, which is our next generation provision IOPS volume. Gives you up to 64,000 IOPS, gives you up to 1,000 megabytes per second in throughput, up to 16 terabytes in capacity. But a couple of key things that customers love about IO2 is its 5 nines of durability and getting 500 to 1 IOPS to GB. To put this in perspective, the durability of IO2 is 100x better than IO1, and the IOPS per GB, which is 500, is 10x better than IO1, all at the same price as IO1. And it's no wonder that a lot of customers have looked at IO2 and decided they want it for their workloads. Well, we're going to raise the bar on that again. At reInvent, we're now announcing a preview of what we're calling IO2 Block Express, which is really the first SAN built for the cloud. This is available in preview. And to give you a perspective of what this means for customers, compared to having 64,000 IOPS, on IO2 Block Express, you can get up to 256,000 IOPS. You can get up to 4,000 megabytes per second and up to 64 terabytes of capacity, quadrupling what we just launched in August, right? Preserving the 5 nines durability and now gives you sub-millisecond latency. So super, super compelling for customers who have workloads that traditionally needed SANs to look at this option and see if it enables their move to AWS. But in launching IO2 Block Express, we took a look at our pricing structure for IO2 and IO2 Block Express. And what we did is lower the tiered pricing per volume for IO2. So up to 32,000 IOPS, you pay 6.5 cents per IOP. But between 32,001 and 64,000, we reduced the cost 30% to get you to 0.046. And then greater than 64,000, we dropped it another 30% to get you 0.032 per provision IOP month. In other words, we are making it more cost effective for our customers to have high performance workloads on IO2 and IO2 Block Express. and we love bringing that savings to our customers. And then we took a look at our general purpose volume type. Let's start with GP2. So if you think of GP2, it is really one of the most prevalent volume types that we see customers use. Customers get up to 16,000 IOPS, scaling at 3 IOPS per GB. You can burst up to 3,000 IOPS for volumes that are less than 1 terabyte. You get up to 250 megabytes per second of throughput. It is great for boot volumes, it is great for low latency applications, and it is great for bursty databases. And it is very, very commonly used by our customers. And you can see some of the customers that use GP2 volume type. So why is GP2 popular? Customers like that it is simple. You only have to provision capacity and you're off to the races. Customers like that it works at all volume sizes. Even small volumes get IOPS with burst. And customers love that it is flexible. You get consistent IOPS scaling at 3 IOPS per GB, and so you understand what performance characteristics you're getting. Here's an example from our customer Experian. Experian has an analytics application, really has a set of analytical tools called Ascend that they used EBS general purpose SSD. It gave them the best balance of price and performance. And in this case, what they shared is they have a single Ascend product that uses up to 2 petabytes of data. It has reduced their production cycle from years to under 90 days. They've created a COVID-19 pandemic tool in less than 30 days, helps them restore customer data in minutes, and helps them test, analyze, and manipulate over 3 petabytes of data. Right? Really solves a huge challenge for Experian. So when we now go to customers and say, what can we do to improve GP2? Really boils down to 3 things. Customers say they want more performance without having to provision more storage. And they would like to see that separation of performance and storage. Then we get customers who have colder workloads or workloads that need capacity but not as much performance. And they would like less performance than GP2 offers. And some of our customers want more predictability in performance without having to deal with burst. So to solve that, at reInvent, we are launching GP3, which is the next generation of our general purpose SSD volume. So GP3 is ideal for relational and non-relational databases, for enterprise applications, for containerized workloads, big data workloads, file system, and media workloads. GP3 gives you 3,000 baseline IOPS and up to 1,000 megabytes per second, and you can provision throughput and IOPS separately from capacity. And it gives you up to 20% lower storage prices than GP2 volumes. To give you a direct comparison between GP2 and GP3, here's what it looks like. You get 1,000 megabytes per second of throughput. You can independently scale IOPS and throughput, and you get up to 3,000 IOPS without burst as your baseline performance. And you can use elastic volumes to migrate from GP2 to GP3 without any application impact. So we've made that transition easier as well. When you look at it at a graph, here's what it looks like. So GP3 gives you 3,000 IOPS up to 120. It gives you 125 megabytes per second of baseline throughput. And then instead of having a linear scaling IOPS across the range, you can provision IOPS up to 16,000. So both GP2 and GP3 have the same peak, but you have the flexibility of provisioning 16,000 IOPS no matter what the capacity of the volume. So what does the pricing look like? And basically for pricing, we've split it into three dimensions. You get capacity, you get IOPS, and you get throughput. And so for capacity, the price is 20% cheaper than IO2. For most volumes, customers, that is the only dimension customers will deal with. and you can get up to 3,000 IOPS and 125 megabytes per second, and you pay 8 cents a gigabyte month. For IOP, between 3,001 and 16,000 IOPS, you pay 0.005, so half a cent per IOP month. And for throughput, you pay 4 cents per megabyte per second month, between 126 and 1,000 megabytes per second. Here's a customer quote from our partner Teradata. And what Teradata says is, with GP3, they get the right balance of price and performance. It allows them to scale their throughput by 4x, and by scaling that throughput, they can reduce the number of volumes that they have to connect, which then improves their instance level availability. It is a game changer for their specific workload, so they are excited about this. Let's now compare how GP3 and GP2 would look like, because now we have multiple dimensions compared to a single dimensions. So help you understand how this would look like in terms of real workloads. So here's a web server, and the web server needs 50 gig of capacity, 2,000 IOPS, 40 IOPS per GB, and 32 megabytes per second, right? If you now look at GP2, you can use burst for the traffic. You'd provision 50 GB, you'd get up to 3,000 IOP, and that's sufficient. And for that, based on US East 1 pricing, you would pay $5 a month. If you now look at GP3, you provision 50 gig, you get 3,000 IOs that are included with the storage, there's no burst, you get 125 megabytes per second of throughput included, and the US East pricing on that is $4, which is 20% lower. Okay? So now let's look at a small MySQL database. This is a relational database that is transaction-driven. So you can see that it is driven in terms of IOPS. Let's say here you need 200 GB, 5,000 IOPS, you need 25 IOPS per GB, and 80 megabytes per second. So in GP2, what you would need is to scale the volume up to 1.667 terabytes. And the reason to do that is you need 5,000 IOPS. And then you'd get a throughput of 250 megabytes per second, and you'd be paying $166.67, again based on US East 1 pricing. With GP3, what you end up doing is you would get 5,000 IOPS, you would get 3,000 IOPS, and then you'd provision up to 2,000 more to get 5,000. Your volume size is 200 GB, so no over-provisioning of capacity there. And you get 125 megabytes per second of throughput, and your IOPS per GB is 25. And then, again, your total price, based on US East 1 pricing, is $26. That is 84% lower compared to the price that you saw with GP2. By provisioning capacity, IOPS, and throughput independently, we are able to give you a lower price point. And that is how across the portfolio, with GP3, with IO2 and IO2 Block Express, with SD1 and SC1, we are giving you a way to reduce the TCO for your workloads. Let's now look at elastic volumes. So on elastic volumes, one of the very common patterns that we see customers do is migrating from on-premises onto the cloud. And what they do is they can migrate to an IO2 volume, tweak around with a GP3 when they feel comfortable, and just use modified volume without impacting their application to go from GP3, from IO2 to GP3. Elastic volumes also allows you to size your volumes correctly. So you can start with a small IO2 volume. As your workload increases, you can increase the IOPS and the size requirements, and that allows you to scale as your workload need changes. We also see customers who tier their volumes across different volume types. So they go from GP2 to SC1 and from SC1 to GP2 as their workload needs change. That allows you to store at the cheaper cost of SC1 while getting the performance of GP2 or GP3 now when you're connecting it to an EC2 instance. just bear in mind that you have a 6-hour EV time limit and how much time it takes to modify your volume. If you have a predictable schedule, this will really give you the capabilities you need. And we looked at these patterns and started to integrate that into our automation. And what we're doing is we've integrated these into our AWS Compute Optimizer, where we can optimize your provision IOPS setting on IO1 and IO2. We look at thousands of workloads, look at your specific workload, and generate recommendations for you. Then we optimize the size of your GP2 volumes in case you need more performance. And then on GP3 volumes, we make IOPS and throughput recommendations based on what you use. And so that comes prepackaged, and using this AWS Compute Optimizer will allow you to save those costs even further. And so that's the discussion, right? And here are the key takeaways. Think about GP3 and how to provision capacity and performance. Think about elastic volumes. Think about the 40% price drop on SC1, how you can use SC1 with the new minimum volume size. Think about the tiered IOPS pricing on IO2, DLM for snapshots and armies, R5B instance to consolidate your workloads, and Compute Optimizer to optimize your volumes. We are excited that these give you the tools to bring cost optimization to your enterprise workloads. At reInvent, these are some other sessions that are ongoing with EBS. Do take a look at them. These are some links that you can go to learn more about these features and capabilities. Other than that, thank you so much for listening to the session. Thank you for being AWS and EBS customers. For those of you that are on social media, you can reach me at Logical Block. Thank you for your time this afternoon. Please complete the session survey as you get a chance.